So next up is we're going to take a look at exponential decay. Okay, so now exponential growth and exponential decay are very similar, except in one case, you're getting bigger rapidly, and in the other case, you're getting smaller rapidly. So this is going to feel very familiar. Okay, so we look at this equation. This equation, compared to the equation that we used for exponential growth, they're almost the same. The only difference is that you're subtracting your rate instead of adding your rate. Okay, so bigger plus smaller minus. Okay, so what we're kind of doing here is in the same way to find your final amount, you take your initial amount and you multiply it by 1 minus your rate. The 1 is like 100%. So you're taking 100% and you're subtracting out whatever percent you're decaying by, and then raise that to the time. Okay, so when we look at this example, we get a new car that costs $26,000. Okay, each year its value depreciates at a rate of 15%. That is true of cars, right? Cars lose value over time. So that would be 0.15 as a decimal. So that's going to be our R. So our model is going to be Y equals 26,000, that's our initial amount, times 1 minus our rate, 0.15, raised to whatever the time amount is. So I can go ahead and simplify that a little bit, subtract the 1 minus 15, that's 0.85 raised to the t. All right, and there's our model. So the second thing that we're going to do is we are going to graph this equation. So I'm going back to my calculator, y equals 1,000 times 0.85 raised to the x power. All right, and now let's think about our window. So we're looking at time again. So going from, I'm at -2 to 20, that's fine, 20 years, sure, right? But in terms of my y's, now the value of the car is starting at $2,600, and then it's going down from there, it's decaying. So I want to make my y max maybe $27,000, okay? And my y min, I don't know, let's just go with like -2, just so we can see where the axis is. And we can kind of adjust things from there if we need to. And that's actually a pretty good fit. It's always nice when the first time you try it, it works out. So here's my graph coming down like this. All right, and I said my window, we went to a junkyard, right? It's never going to get to a point where it's worth absolutely nothing. It might only be worth $1, but it's worth something, right? So that's what you see happening in this graph. The value is very good when you buy it, right? But as time goes on, that value drops pretty steeply. And then it gets to a point where it sort of levels out. And it never totally loses its value, right? That's where your asymptote shows up. But it is constantly losing value. All right, so the next question, we're going to find the value of the car after 3 years to the nearest dollar. So that's where t is 3. And again, if I hadn't already graphed this, I would have thrown this in to the equation and used that in my calculator. But since I did already graph it, I'm going to hit trace and type 3 and hit enter. And there you go, it spits the number out for me. So that is $15,967 to the nearest dollar. Okay, so think about that. 3 years, right? You bought a car for $26,000, and 3 years later, it's only worth $15,000. Take a look at Kelley Blue Book sometime. See how accurate that is for a 3-year-old car compared to its selling price. All right, next question is, when is it going to be worth $5,000? Later in the semester, we will learn how you can solve this algebraically, but for the moment, we are going to use our calculator. Okay, so we're going to come here, put a separate equation for 5,000. Go back to my graph so that'll show up, and I want that intersection point. So I'm going to calculate. Option 5 is an intersection, and there it is. So that happens when x is 10.1. So when is that? So after about 10 years. And there we go, that's exponential decay. So if you're all set with exponential growth, exponential decay is really not much more of a continuation. You notice that there's no compounding decay. Okay, that's because compounding interest is really a thing that happens with money. That's a money thing. And you don't have anything where you're going to compoundly lose money, right? So that's why we don't worry about that one at all. Okay, so there's no compounding decay. Things that you're going to see compounding decays, anything where you have something losing value like this, medicine, when you like take a certain medicine, the way that it drops out of your bloodstream, that's an exponential decay. When you have like radioactive isotopes that are decaying, that's exponential decay. So those are some of the examples. You'll see a lot more as you go through this.